In this video I'm going to give you an explanation as to why when you have a function and then you apply a transformation like this, it will in effect turn the graph upside down. So for example, if you have a function like f of x equals x to the power of 3, we know the graph looks like this. But then I'm going to give you an explanation as to why when you apply this transformation, negative f of x, then it would turn the graph upside down. So let's investigate with f of x equals x squared. So normally what goes in this box is you putting 0 into here. So what goes in this box would be f of 0. But then what is f of 0? Well, 0 is here, f of 0 is 0. So what goes in here is the number 0. What goes in this box would be you putting 1 into here. So it would then become f of 1. But then looking at this function, what is f of 1? Well, 1 is here. So f of 1 would be this point here, 1. So it would be 1. Hang on, it would make sense later on, bear with me. So what goes in here would be you putting 2 into here, so that would then be f of 2. But then what is f of 2? Well, f of 2 will be 4. It would be the number 4. So what goes in this box would be the number 4. So hang on, let me clean this up. So what goes in this box would be you putting negative 1 into this x here. So what goes in this box would be f of negative 1. Then what is f of negative 1? Well, negative 1 is here. So when you jump to the graph, it will give you the number 1. So what goes in this box will be the number 1. What goes in this box would be you putting negative 2 into here. So that would be f of negative 2. What is f of negative 2? Well, negative 2 is here. F of negative 2 is actually the number 4. So what goes in this box would be the number 4. Okay, now the important part. We are trying to investigate what this thing is doing minus the original f of x. So let's have a look at this one. What goes in here would be you putting a 2 into here. So that would be negative f of 2. But what is f of 2? F of 2 is 4. We just did it earlier. F of 2, look. F of 2 is the number 4. So, but then you've got a minus in front of it. So that whole thing there will become negative 4. It will become negative 4. Okay, what goes in this? Hang on, let's do this one here. What goes in this one here? Well, you would put negative 2 into here. So that would be negative f of negative 2. Because you've got a negative in front of the f of whatever. You've got the negative in front of f of whatever. So what is f of negative 2? F of negative 2 is the number 4. It's this thing here. But now you've got a negative in front of it. So the whole thing here would become negative 4. So what goes in here? Hang on, let me clean this up. Oops. Let me clean this up. So now what goes in here would be minus and then f of negative 1. F of negative 1. Well, f of negative 1 is this number here, 1. But don't forget you've got a minus in front of it. So it becomes negative 1. Negative 1. So basically it's going to become the negative of this. Negative 1. 0, negative 0. But then negative 0 is 0. So we just leave it as 0. So now if you look at this point here, if you look at x equals 2, f of x is normally 4. It's normally 4. But then this thing that we're trying to investigate is negative 4. So it would jump to negative 4. So this point here will then jump all the way to negative 4. It will then jump. This point here will jump all the way down here. So that would then become this point here. Hang on, let me clean this up. Bear with me, it will make sense later on. So let's look at this point here. When x is 1, so when x is 1, f of x is 1, So that's this point here. But then the thing that we're investigating is -1. So we'll jump to -1. So we'll jump to here. So this point here will get moved down to here. 0 gets moved down, well, it stays the same. 0 jumps to 0. So this point here will stay still. It will stay at the origin. If you look at this point at -1, when x is -1, when x is -1, normal f of x is 1. But the thing that we're trying to investigate is -1. So it jumps to -1. So this point here will jump all the way down here. So it will then become this point. And then if you look at this point here, at x equals -2, x equals -2, normal f of x is 4. Normal f of x is 4. But the thing that we're trying to investigate is -4. So this point here jumps to -4. It will jump to right here. It will jump to right here. So in effect, what you're trying to investigate turns out to be this thing here. The act of you sticking a negative in front of it just turns everything. +4 becomes -4. +1 becomes -1. By you sticking a -1 in front of it, you're just moving it into the negative realm. So this point here moves down to here. That's why when you apply this transformation, the graph turns upside down. So if you look at this, hang on. So if you have a function f of x equals whatever, if you have a negative version, it will just turn it upside down. So if you jump to Desmos and punch this in, f of x equals x squared, that will then give you this red line. But then by you doing this minus f of x, it will automatically draw the negative version. It will just turn it upside down. Okay, so if you look at x to the power of 3, f of x equals x to the power of 3. Normally when it's 2, it jumps to 8. But then if you're trying to investigate negative f of x, you've got to stick the negative in front of the 8. So this +8 becomes -8. If you look at 1, 1 to the power of 3 is 1. If you stick a negative in front of it, it will become a -1. And then 0, it would be 0. But then this thing here, if you look at -2, -2 jumps to -8. But then if you're trying to investigate this thing, it would be minus, which is this minus here, minus -8. So that becomes a +8. So this point here gets moved up to here. So it would be here. And then this is -1. It will move up here. So basically you're going to get a graph looking something like this. It's an upside down version of the cubic. Well, in summary, if you have this function and then you apply this transformation, it just turns the function upside down. Okay.